about you. So this is going to be the key, just so you know. I'm going to try to write as little as possible, just so my pen doesn't make the clickety-clackety noise. So first one, we got metric conversions. I'm going from meters, which is a base unit, so is seconds, so is liters. I got meters, meters again in that case, and grams. So those are my base units. Remember, that's in the center. So I'm going here from meters to kilometers, which means I'm moving 1, 2, 3 spots left. So let's undo that. I'm moving 1, 2, 3 spots left. This gives me 0.0347 kilometers. Okay, here we have 1.6 seconds. Okay. And I'm going to centiseconds, so that means I'm going from base to centi. So that means I'm going to move 2 spots right, so it's 160 centiseconds. Going from kiloliters to liters, that's 1, 2, 3 spots right. Moving my decimal 1, 2, 3 spots right gives me 340,000 liters. Next, I'm on kilo to meters. So kilo to base units is again 3 spots. So it's 1, 2, 3. I get 81700 meters. Here I'm going centi to milli. I'm going 1 spot right. So it's just 108 when I move it 1 spot right. Here grams to milligrams is 3 spots right. 1, 2, 3, which is going to give me 65700 milligrams. Okay. Next, scientific and standard notation. So positive exponents means I make it bigger. I just move the decimal 5 spots. 1, 2, 1. Oh, what is going on here? Let's cut that. 1, 2, 3, 4, 5, which means it's 62 with 4 zeros after it, 620,000. Here I'm moving it 2 spots, so it's 1, 2, which is going to give me 870. Positive means big. And here it's negative, so I move it 1, 2, 3 spots left, so it's 0.0023 there. Now, nice part about scientific and standard notation is my decimal. I can kind of place in advance because I only want 1 digit in front of the decimal place. So 1.0, 2.5, 4.33. And then it's times 10 in each of these cases. And then I have to figure out how many decimal places I moved it. Here is 1, 2, 3, 4, 5, 6. So it's 10 to the 6th power. Here it's 1, 2, 3, 4, 5, 6. So it's 6th power. Sorry, I'm going to double check. 1, 2, 3, 4, 5, 6. Yep. Then here it's 1, 2, 3, 4, but it was small, so it's also negative 4. Okay. Here, these are all dimensional analysis problems. So one thing to note, when I'm going metric conversions here, what I'm doing is these are both, notice, meters to meters. So it's the same units. In our dimensional analysis problems, going centimeters to inches, which if I look over here, I have how many centimeters are in an inch. So that means that I can't move the decimal. I have to actually do a calculation. So you start by writing your starting units, and then figure out what you want to go to. So centimeters goes on bottom, inches is on top. Whatever units I start with always goes on bottom. Okay, that's an important part of this process. So then I look at this and it's 2.54 centimeters. So I find where centimeters is and put 2.54 in. It's 1 inch. So I put 1 with inch. Top means multiply, bottom means divide. So it's 2004 divided by 2.54. Times 1 gives me 788.9. I'll just say 789 inches. Here I have 1,500 grams, and I want pounds. So same idea. Grams is going to go on bottom. Pounds is on top. It's 453.6 grams per pound. And that's what I see right there in that conversion factor. So multiply and divide. So 1,500 divided by 453.6 gives me 3.3 pounds. 20 meters to yards. I got 20 meters. I want to go to yards. Let's just make sure. Yep, I'm using this conversion factor right there. So I have 20 meters is equal to yards. How many yards? Meters is on bottom. That's 0.9144 meters per yard. And 20 divided by 0.9144 gives me 21.9 yards. Last one, I have 0.45 gallons, and I want to go 2 liters, which means gallons has to go on bottom to cancel, liters on top. And I'm looking right here. 1 goes with gallon, because that's what I see here. And 3.7854 liters goes on top. Multiply and divide. 0.45 times 3.7854. Oops, plugged in my calculator wrong. 0.45 times 3.7854 gives me 1.70 liters. Okay. So we're just doing some vocab fill in here. So physical sciences study mostly non-living things. I'm just gonna I'll use text box now. There we go. And the amount of sunlight is the only difference between 2 setups and control experiment. The sunlight would be the variable. Okay. When scientists set up an experiment, they always have at least 2 parts. The part that never changes is called the control. Blank is the measure of the amount of gravitational force exerted on an object. That would be weight. Okay, so hopefully as you're going through here, you are editing weight. Blank is a description of how close a measurement to the true value it is. Okay. And that would be, let's move this box down. There we go. That would be accuracy. Okay. And I want to draw it. What's happening here? Sorry that this is being so stupid. The exactness of a measurement, there we go, is precision, how repeatable it is. The knowledge gained by observing natural events and conditions in order to discover facts and formulate laws and principles that can be verified and tested. So say you weren't sure, you're like, okay, I've used weight, I've used weight, I've used precision, I've used control, I've used accuracy, I've used variable. So I got law, theory, and science left. Well, out of those 3, the one that certainly makes the most sense to me, and this is a possible test-taking strategy for you, and this is the actual answer, is science. Okay. Next, both of these are based on scientific observation, experimentation, and reasoning. Okay. But the difference is explanation or description. So the word that you often see with this one also is description, often represented by math equations. That would be law, and this would be theory. Okay. A couple parts left here. We need to determine the acceleration of gravity. That would be the problem. We found what it is out to be. That would be your conclusion. Your guess is your hypothesis, and your experiment is what you actually did. Hypothesis can never be proved wrong. That's false. Okay, what type of graph? This is a line graph. Notice we have data points that are connected. In general, did smoking become more or less popular from 1960 to 2000? So let's look for 1960, which is right here. And right, and we're going to year 2000. And you could answer this a couple different ways. Okay. So if you look at the women line, the women went slightly more. We'd say an increase of about 100 people. The men decreased from 1,600 to about 200. Okay, so that's a loss of 400. So women gained about 100, men lost about 400, even though they still smoke more. So that's an overall net loss of 3,000 people. So overall, we'd say less. So what years did women increase the rate of smoking? Overall, you'd say, so they definitely decreased from 80 down. And you'd say maybe it stayed the same from 75 to 80. So we'll just say from 1960 to 1975, it went up. What type of graph is it? To the right, sorry, it should be above. This is a pie chart. Most common letter grade, just look for the biggest slice, or you can look at the percentages, and that would be letter B. What variable always goes on the X? That would be the independent. The dependent is Y. Okay, so now we're graphing here, road trip and elapsed time and distance. So this is I'm just gonna say time versus distance. I'd say for Duluth road trip. So make sure you have a thing going on here. So which one's going on the x-axis is the one that I am changing, which would be time in hours. Oops, don't want that. Which one am I measuring? Turn to my iPad here. I'm going to measure miles, and let's say, make sure we use what it says here, distance traveled in kilometers. Okay, that's my fault. So I'm going to use distance traveled. In kilometers. Okay. Now figuring out my keys. So I have 5 hours. So if I look at this, we're just going to kind of ignore this little sliver here, like that part right there. We're just going to, maybe color that out so I'm not using it. So clearly if I counted 1, 2, 3, 4, 5 and put 5 right there, I'm not using enough of the graph. Okay. So that means I need to figure out about how many. And I could count it over 1, 2, 3, 4, 5, and so forth. But basically, I'm just going to say every 5, 1, 2, 3, 4, 5. I'm going to put 1. 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 5, 3. 1, 2, 3, 4, 5. And that would allow me to go 1, 2, 3, 4, 5, and put 6. And, I'm using most of the space here. Distance traveled is 250. This one would probably be more helpful for me to count. I just know for sure, I don't want to take the time as we're watching the video to count it out. So I'm going to estimate. One way to do it, let's say there was 30 of these. You'd say, I want to do 250 divided by 30. That means every one needs to be at least, roughly 7. Okay, well, let's just say that every one of these needs to be 10. So 10, 20, 30, 40, 50 is going to go right here. 1, 2, 3, 4, 5. 100 is going right there. 1, 2, 3, 4, 5. 150 is going right there. 200 is going right here. 250 is going right here. And 300 is going right there. And you'd go so forth up. Okay, I'm not going to spend a bunch of time doing that. So my first data point is 0, 0, which is going to go right there at the bottom. The next one is 1 and 50. So 1 is right here. 50 is right here. Let's go 2, 100. You're traveling at a very consistent speed. You clearly have your cruise control on. I'm going to go 3 and 150. I'm going to go 4. And 200, go 5, and 250. If I look at this, I have a pretty linear relationship here. Let's see. If you just hold it on your screen, you see how it gives me a straight line? I'm able to do that. That's pretty cool. Okay, so how to be able to predict. So 6 and 300 would be right here, right? So that would, in theory, be able to predict the time versus distance. So that's all we got here for the practice test. Make sure that you're aware of all those pieces. Love you guys. Appreciate you. Have a great week.